Alright guys, so what we're going to be learning today is quadratics on a number line. So just reviewing little things on number lines. You know, when we graph things on a number line, we can either have something that's greater than or less than or equal to, or if it's just greater than or less than, it's open or closed circle. And just reviewing this means that x is in between two quantities. So let's say this is 4 and this is 9. We would say x, let's just make this an open circle. So if x was in between these two numbers, we would say 4 is greater than x, but it's also smaller than 9. Or we can have inequalities where two numbers, let's say 4 and 9, and it could be x is less than or equal to 4, x is greater than or equal to 9. Just reviewing, pretty simple. Now on the notes, what I say is, when you are given a quadratic inequality, pretend the inequality does not exist right now. So look at the example question I'm giving you. I'm saying, all right, let's say x squared minus x minus 6 is less than or equal to 0. We're going to pretend for right now, we're going to rewrite it just to solve it, that we have x squared minus x minus 6 equals 0. So once we solve it, we're going to do this. X minus 3, you know, it's just a simple factoring problem. And we're going to get x is equal to 3, x is equal to negative 2. Okay, but this isn't true. It's not equal to. It's inequalities. Now I'm going to show you something. If we have x is less than or equal to 3, x is less than or equal to negative 2, let's plug in let's say x is less than or equal to, let's plug a data point here. Let's say 10. Let's just use 10, because 10 is less than or equal to negative 2. I'm sorry, negative 10. Negative 10 is less than or equal to negative 2. But watch. Watch if I plug in a negative 10 into this original equation. Negative 10 squared is 100. 100 minus or plus 10 minus 6 is not less than or equal to 0. This will not be true. So once you get the answers might not necessarily be all true. So what you have to do is you have to pick a number and figure out whether you're doing less than or greater than. These are called boundary points, 3 and negative 2. So on a graph, here is negative 2 and here is 3. I know it's going to be equal to. So these are my two boundary points. Now I have to choose a testing point. The easiest testing points is choosing 0. Let's choose 0. And if 0 is true, then we're going to include 0 in this and this. So we are going to get rid of these inequalities right now. Let's choose a 0. 0 squared minus 0 minus 6. So you know negative 6 is less than or equal to 0. That is a true statement. So we are going to create two equations where 0 is included in the boundary. 0, if we do x is less than 3, 0 is included in that. And if we do x is greater than or equal to negative 2, then 0 is included in that. So let's say x is less than 3, but it's also greater than negative 2. This is what our solution set looks like. So recapping, you have to find your two boundary points. Plug a point into the equation to see if it's true or not. And set the second step on your notes. Once you solve it, part of your solution will not be true. Third step, choose a number to include or not include in your data, and then graph accordingly. All right. So here's the graph. The solution set would be x is in between -2 and +3. Okay, let's do the second equation. X squared minus 5x plus 6 is less than or equal to 0. I give you the solution right now on the notes, but we're going to go ahead and do this. I'm going to make this equal to 0, and I'm going to solve. X minus 3 times x minus 2, and then I get an answer of +3 and +2. So on my graph, here's 2, here's 3. We have to choose a data point that's in the middle of it. So in this case, we can't use 0. We can use 0 starting off. Let's do 0 for here. Let's plug in a 0, see if this works, and I'll show you why I'm doing this in a second. All right, 0 squared is 0. 5 times 0 is 0 plus 6. 6 is greater than or equal to 0. That's a true statement. So with my answer of 2 and with my answer of 3, I know that x is, starting from 2, x is less than or equal to -2. But I can't say, watch this, I'm just doing from 2. I can't say that x is less than or equal to -3. I don't know that, because what if I were to plug in a 2.5? If I plugged in 2.5 into here, I don't know if this is going to be a true statement, which is not going to be, by the way. So all I know from 2, I can include this. X is less than or equal to -2. So this means this graph is going to go this way. Now let's plug in a data point for number 3. Let's use 4. 4 squared is 16. -5 times 4 is -20. Plus 6 is greater than or equal to 0. -6 or 16. -20 is a -4 plus 6. All right, so we have 2 is less than or greater than or equal to 0. That is a true statement. So luckily I didn't graph this, because I know that 4 satisfies this statement. So that means from my 3, I'm going to include 4. And my 2 answers are x is less than or equal to 2 and x is greater than or equal to 3. All right. So recapping, choose a data point from both ones. If we could have chosen, technically, we could have done this. This might have been easier. We could have tried 2.5. 2.5 would not have been true if I plugged 2.5 back in. That means 3 would not be able to contain 2.5. 2 would not be able to contain 2.5. I just used 2 whole numbers, but you have to use a data point or 2 data points in there sometimes to see where you're going to be graphing. Okay, the very last equation. All right, very last equation. We have -x squared minus 3x plus 5. We're just going to pretend it equals 0 right now. Then I would use a quadratic equation to get x equals -b plus and minus the square root of b squared minus over giving me a solution, and I give you the solution. I say x is equal to 1.2 and x is equal to negative 4.2. Now, what I'm going to do is I'm going to plug in the answers on my number set. I'm going to use negative 4.2 and 1.2. Now look, I'm going to use a 0. 0 is in between these two. Let's see if 0 works. If I plug a 0 into my equation, I get 0 squared minus 3 times 0 plus 5 is greater than 0. That's a true statement. So that means that this and this data set has to include 0, giving me an answer of negative 4.2 is smaller than x, but x is smaller than 1.2.